In this video, we're going to discuss about the centroid. Let's say we are given an object, like if we are given an object like this, then here in the middle, I draw a line there. All right. So if we have this line, I can say this distance from there until there. I can call this distance there. That is our depth. We know this will be what? Our depth, right? So here we'll have our base. This is from where? It's from there until here. All right. So the distance from here until there, this distance there, we'll call it x bar. Then the distance from there until here, we'll have this to be what? This we call this y bar. All right. These two, you see these two lines where they meet here at the center here, we'll call that, it's where we'll have the position of what? Of the centroid. We have there our G, position of what? Of the centroid will take place there. All right, that is what we'll have there, the position of what? Of the centroid will take place where? Here we'll have our G will take place there. All right, so if we're given this, we know that the area, if we're supposed to calculate the area of this object, all right, the area will be what? B. There we have our base multiplied by what? By our depth. All right, then what about x bar? What will be our x bar? X bar is the position of the centroid from the vertical, like will this position from here until there. A CDC will be what? B will be base, divide that by what? By 2. All right, then what about our the y bar? What will be our y bar? Y bar will be what? It's a depth, as you can see there, it's a depth divided by what? By 2. This is how we can get it when you're dealing with what? With a square. We've given this section of the rectangle, or I can say square, rectangle or a square. If we're given this object to be a rectangle or a square or a square, this is how you go about determining. We know the area will be the same. This is how you go about determining y bar and x bar. And in x bar, where they intersect here, that will be the position of the what? Of the centroid for this object. All right, as you can see them. So they can give you these two objects. Remember, they can give you a combination. This is a singular one. I can give you this combination. We can give you the combination. We can give you the squares like this. I can put on top of each other. As I have the square like that, then I replace another rectangle there on the at the base. I can put a rectangle like this. We can have a combination. We can have this as a combination. Here we'll have rectangle and the square, right? So we know, if you take if you may note, our center here, we've said we'll do like this. Here we'll have our horizontal line, and then here exactly in the middle we'll have our this thing, the distance from there until there going up. We said that it's what? It's y bar for object 1. Can call this one object 1, can say this is object 2, right? For object 1, that will be our y bar. You can say y1 like that. All right, you can call that y1. That can be a y1. So y1, then from, we said from that question, we said the distance from there until here, there at the x-axis, this will be what? Our x bar, right? And then where they intersect, that is where we'll have our position of the what? Of the centroid. You can see that is G, our centroid there for object 1. But what about object 2? Object 2, remember we already have our x bar there, but here we are focusing on the center of this object there. The center will be somewhere here. We'll have our center there. All right, but now y bar from that object, let me just increase this a little bit, elongate this. So from there, now will be from there, from the bottom. Remember, we take it from the bottom until there. This is now will be what? Our y bar 2 for the object 2. We'll take it from the reference, our reference from the bottom. Y bar is calculated from the bottom, not from the bottom. We take this from where? From the bottom, then going upwards. Are we together there? So x bar, we take it from the vertical, but origin, you can say this from the horizontal. If I can make the line like this, the way it starts from there, this is the distance from there. We take it from the side where this thing, where the bottom, this distance. Now x bar, the second x bar will be the same. You see, you have here x what? X1, then x bar 1, you can call that. Also x bar 2 will be from there, from here until there, will be the same as that. That is x bar 2 will be the same as that. So this is how you find, this is a center there, this is a center, right? But now to find the, it's all about that notification. But now, since we have the combination, we have to use how can we find the centroid combine of this object? That was the centroid for each. We don't know where the centroid will lie as a combine object. How can you get the centroid of this combine? So we'll check how can we get that, right, to find the centroid. Maybe the centroid can be here, the real centroid when it's combined of all, combining all these objects. What will be the centroid for the entire object? Maybe it can be somewhere here there. So we'll evaluate, it can be given in this format. So that is what you're supposed to know again. That is what you're supposed to know. They can give you something like that. All right, are we together there? They can give you something like that. So we can have again you can given the shape, the square, a circle. You can have a circle, you can have a circle, you can have a circle. All right, having a circle, we're still going to have that the center. We're still gonna have our center like that. All right, also we're still gonna have the line that goes there. All right, here we'll have our window. From here, from the bottom, we are checking this line there from the bottom there until the bottom part like this. From this bottom we'll have our y bar, that will be y bar. Then x bar obviously can be from there where the start of this, the start of this object, from there until goes like that, we'll have this to be x bar. So where they intersect here, we'll have G there in the intersection, a point of what of the centroid. Remember, this is simply what our radius. Then we can draw this. You can have a diameter there. So anyways, there is our centroid. Will be there the center. We know calculating the area of the circle cross section is 4 pi d squared, right? This is our area to determine the area. But now to find y bar will simply equals to what? Y bar will be given by what? By diameter now, divide by what? By 2, right? That is what we'll have now. And what about x bar? X bar will be the same as this one, also will be diameter divided by 2. When you're given the circle cross section, this will be the same. Y bar and x bar will be the same, right? Will be the same, or can be a radius, or can be what? A radius. That is what we're supposed to know to determine the centroid of that shape, which is the of the circle. So we can have again the rectangle. We can have the shape. We can have our rectangle. All right. So we can have our rectangle like that. So from this distance there, bottom, can call that will be h, the height of this, that is the height. Y bar now, what about the y bar? Y bar will be from here, will be from there until somewhere there, going like that. That is our y bar. This is simply what y bar, this distance there, it's y bar. So what about the x bar? X bar will be from here until somewhere here, until somewhere there. This is x bar. Then you go up like that, where they intersect there. From that intersection there, we'll have our centroid there. You see, now we know to calculate the area of this. We know that the area is calculated by, of the rectangle, it's 1/2 b multiplied by what? Okay, I can say this distance again. From here until there, we know this is what? It's our base. We'll have our base like this. So will be base multiplied by what? By height, right? This is our area. What about y bar and x bar? All right. What about y bar and x bar? Y bar will be given by 1/3 multiplied by h. Also x bar there will be given by 1/3 multiplied by what? By h. That the position of what? Of the centroid. Of the centroid, guys. So this is what we have. All right. So we have this typical question here. We have this typical question read as follows. Says determine the position of the centroid of the shape in figure 6.10. Remember, we don't know. Maybe the centroid, the position can be here. We don't know where it can be in me, because this of the whole subset maybe can be there. So we're supposed to determine that. To determine that, there's a special formula we're supposed to use. All right. It's a special formula we're supposed to use. We have things that we're supposed to apply that I will show you how to combine that, right? So to use that, there's this formula that we're supposed to use. The total we want determine the position of the centroid of the shape. We want y bar. All right, from the axis like going up. There's this formula that says area. We have a total area for combined object. It's a total multiply by total y bar like this. This must be equals to area 1 of the object 1 multiplied by y of the area of the object 1 plus area of the object 2 multiplied by y of the object 2. So if we want, we can make this the subject. If we want this, we make it what the subject of the formula. Therefore y bar, our y bar, this is our total one, the one that we want of this object, will be area 1 multiplied by bar 1 plus, which is that one is simply just okay, or it's y bar, it's y1 actually, plus a2 multiplied by y2, then divide by the total area. Total area is just the sum of the two area. Divide by what? By the total area. Then this is the formula we can use if we are not given a single object. We know when you're given a single object, this is a straight one. Now we're given what? The combination. We'll apply this. We'll need the area 1, area 2, y1, y2, all that. Okay. So we have talked about y bar. So let us check the y bar for this. Is an object 1. This is a object we can put here. This will be object 1. This can be object 2. All right. So there you check. We want y bar. Y bar from this whole page will be what? 60 divided by 2 will be there at the center, as I've shown you. Because this is a square, we'll have our y1 there. All right. Will be what? 60 divided by 2. This is what? It's a y1 there. Will simply equals to what? To 30. That's distance will be 30, obviously millimeter. Then we have now it's y1 of this object 1. What about the y2? Is supposed to be in the middle, like again of this object. If you go like that, if we cut that object from the bottom, remember we take the reference from the bottom. We'll have our y2 from the bottom here, y there, it will be y2. From there we'll have what will be this distance. From there will be what? From the center of this 50 divided by 2, this distance here will be what? This one will be 25 plus 30 will be, this will be what? 25 plus 30. Yeah, this one will be 25, that distance. The half here, this half part will be 25 because it's at the center of what? Of 50 there. So here we'll have 25 plus 60 will be 85 millimeter. But actually, no, even if I don't use that, but I know this will be millimeter, right? So you are wanting the centroid. Maybe might be here, the centroid of the combination of this object. So how can we get that? Will be added by our formula. Now we have y1 and y2. We can find the area of the object 1 and object 2 applying this formula now. All right. So allow me to erase this. We will rewrite that. There's no problem. Or let me not erase. Let me just resize this and put it aside. We will use it. Let me put it aside. They will use it when it's needed. So we've seen we're supposed to find area 1 on our formula. We can get the area 1 for object 1. What is the object 1? Is this square, guys, the bottom square. We're talking about the square here, that the area of that square that I've highlighted by pink. We have 60 multiplied by that will be 60 multiplied by what? By 70. What will be our area there? If we multiply, will be 4,200 200. Obviously this is millimeter squared. This is what we have in millimeters. All right, what about the area 2 of the object 2? Object 2, it is here. That is object 2, the one that I'm highlighting there at the top. We have what? 50 will be 50 multiplied by what? By 40. Now we'll get the area there will be 50 multiplied by 40. This will give us 2000. Obviously this is millimeter squared. This is what we have, the area 2. All right, we have the area 2, but what about now? We're supposed to have, from checking from this formula, from that formula, again from this formula that we have there, that we've discussed about, this one, as you can see, we have here at the bottom the total area. So the total area is the sum of these two. We have two objects. We'll add up this object, will form one shape, forming that this will be total area, will be area, I can say total area T, like that. I can say this is a total area, AT will be area 1 plus area 2. That is our total area. All right, then we can add up these two. Sorry, can add up these two. We have 4200 plus this area there, 2000. Then our total area will be 6200. Obviously is millimeter squared. We have now this. We have the area 1, we have the area 2. We're left with we have y1 and y2. We have shown there. We have there y2 is 85, y1 is 30. So we'll apply our formula. Now we apply our formula. Just applying our formula now. We can apply our formula. All right, here it's our formula. Now we'll try and apply this. We can just substitute what we're supposed to substitute. Here it's our formula. We know we want our y bar total, or let me just say y bar, there's no problem there. That is what we are wanting there. Can say y bar total, no problem. The center area 1, here we have those areas there. Area 1, we have chosen that area 1 to be equals to what? So we must be careful. Area 1, we have chosen area 1 to be object 1. There's one on the bottom. By area 1 is 4200. Area 1 is 4200. Multiply this by what? Multiply this by bar 1. What is bar 1? Bar 1 is 30. Since we have shown that, we did see that. We've seen that, which is what is 30. We still together. Plus area 2. Area 2, it was 2000. Either way is 2000 multiplied by our y2 is 85 there. As you can see, we have our 85. That is y2. We have 85. Remember, this is in millimeter. That means our final answer will be in millimeter. If you want, you can substitute this to be in meters, but you must know that your final answer will be in meters. The total now over the total what? Total area is the one that we have here. 6,200 200, that is our total. Then I quickly punch this on my calculator. Therefore I'll find that YT there will be equals to what? Will be 47,742. This obviously because it was in millimeter. If you want this in meter, you divide by 1000, or you can multiply this by 10 to the power of minus 3. It's the same as like you divide. If you want that, it's up to you whether you want it in if you want that, you can do that. Then if you multiply that, you divide that, multiply that by 10 to the power of minus 3. Supposed to obtain, this will be 0,04. We have 7742 meter. If you want this in meter, it's up to you. That is YT there. All right, this is what we have, guys. So by the way, thank you for watching. Do not forget to subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post a new video. Feel free to like and share and to comment. All the best.